Hello and welcome back. Alright, so in this section we'll be talking about optimization algorithms. Now, optimization is the way you use to update your weights. So basically it's the method of learning, how your neural network learns. It's called optimization. So in other words, it's how it uses gradient descent. The way it uses it. Okay, so we're gonna look at some of the optimization algorithms, which are the most famous and most used optimization algorithms. So I hope you enjoy this section, and let's get going. So first of all, let's talk about gradient descent. Gradient descent is the base algorithm. It's the general method that is used to update the weights. So like, you can think of the gradient descent as the big guy, the parent of all of the other optimization algorithms, because they're all dependent on this gradient descent base algorithm. This is the base algorithm. Okay, so we've studied gradient descent before in the backpropagation, but let's recap very fast. So you have your weights here, and you have your error function here, and you're minimizing your error function, okay, so it can reach the minimum. Alright, so you're changing the weights in order for the error to decrease. So you want to reach here, you want your error to reach here, the minimum. And how you can do that is you need to change the weight. So that's why we have this differentiation rule, the differentiation of the error with respect to the weight. That means how much do I need to change the weight in order for my error to decrease. So you can think of it as a ball that's rolling down, and then you're calculating the slope. Now, and then you're moving the opposite direction of the slope. Remember, in the backpropagation, we had the this term, which is the differentiation of the error with respect to the weight, as a negative term. All right, so we're moving the opposite direction of the derivative. So if your slope is positive, for example, here your slope is positive, then you're going to need to move the opposite direction of the slope, which is backwards. All right, so you're going to minimize in this case. And if your slope is negative, then you're going to need to move in the opposite direction, which is this way over here. So you're going to need to increase the weight. Okay, so this is the base algorithm, which is gradient descent. Now this is simple two-dimension only. You have these weights and your error function here. Here is the same thing, it's just the 3 dimensions. So here you have a set of parameters. Let's denote these parameters as W2. And of course, these are several weights here. And you have another set of parameters here, which are denoted by W1. And again, they're another set of weights. And you're trying to minimize your error function by changing these weights. So that is gradient descent. That's the base algorithm of gradient descent. Now let's look at batch gradient descent. Now in batch gradient descent, what you do is you take all of your sample one time, you feed them through the network, you calculate the error, and then you backpropagate this error to update the weights. So you're basically updating the weights based on all of your samples. Okay? So all of the samples are passed to the neural network one time. And then you're computing the gradients of the loss function with respect to the network's weight for the entire training dataset. That's what you need to take note of. So you're calculating the loss for all of the samples in the dataset, and then you're performing the weight updates. And in this case, an iteration equals to an epoch. Now remember, an epoch is one complete pass of all of your samples in the dataset. So once you finish passing all of them, then you finished one epoch. But in this case, we're just passing all of the samples one time. Therefore, an iteration equals to an epoch. Now this is not true for stochastic gradient descent and mini batch gradient descent, as we're going to see later on. An iteration does not equal to an epoch. Okay? Because we're not taking all of our samples one time and passing them. But in this case, in batch gradient descent, we are taking all of our samples at one time and passing them through the network, calculating the loss, and then performing the weight update. So this is the weight update rule. Okay? Theta is the weight. So you have your new weight equals to the old weight minus the learning rate times the differentiation of the error with respect to the weight. This whole thing is just another term for the differentiation of the error with respect to the weight. Okay, so this is calculated for all of the samples. This loss function is calculated for all of the samples. Okay, so this is done once you finish passing all of the samples and the data set to your neural network. Okay, so once you do that, you calculate this loss function over here, and then you back propagate, and then finally you update your weights. So if we visualize this, then this is what we have. Let's say that this is your data set. Your data set consists of 8 samples. So in batch gradient descent, you're going to take all of these samples. Okay, so each sample is 3 features. That's why we have 3 input neurons. So we're going to take all of our samples one time, which are here, pass them through the neural network, calculate the error, then update the weights. Okay, so this is batch gradient descent. In the next video, we'll be talking about stochastic gradient descent. So I'll see you next time.